Ever wonder what actually makes your program works? It's all about how you handle data. What are the data types? Why they are critical? Without understanding them, your code is just a jumble of characters. Let me dive into it. So before we start the primitive data types topic, let me go through some basics which are essential to understand these data types. Let's see that. So this is the background I'm going to give you before we jump into the data types. So first is, what is meaning of bit? So bit is basically a smallest unit of digital information. So generally it is a binary representation. When I say binary, it is either 0 or 1. Means what? 0 is 1 bit and 1 is also another bit. Now, this is the smallest unit of digital information. Means what? In digital computers, in your digital devices, mobile phones, etc., all the data is stored in terms of zeros and ones. So this is the smallest unit. Means what? The biggest unit could be 10 bits, 100 bits, 60 bits, 200 bits, 400 bits, 1 crore bits, whatever it is. Okay. Now, this is the smallest unit. Okay, we'll see what are the different unit. We usually call 8-bit representation, 16-bit, 32-bit, so on, so 64-bit, all that, right? So this bit is a smallest unit. Means the information in the computer is stored in terms of zeros and ones. This is the smallest unit, right? And second is byte. Byte is, it's basically 8 bits. So there are, in a byte, there are 8 bits will be there. Let us say these are 4 and let us say these are next 4. Total 8 bits. This 8 bits combinedly we call it as a byte. Okay. Next, this byte can be usually, one byte can be used to represent 256 different values. So having said, I can represent a 0 with 8 bits. Okay. Like this 0, 0. I'll tell you in more detail about this. Okay, and 1 can be represented like this, so on, so 7, last one is 1, and let us say 255 can be represented like all ones, all or totally 8 ones, you can say. So means number 255 is converted into all ones and number 0 is converted into all zeros, 8 zeros. So each 8-bit representation is used to represent a value between 0 to 255. These are 0 to 250 are the decimal values, right? And this is basically used to store a single character. As I said, this is 0 is a single character, 255 is a single character, 1 is a single character, so on. So we'll see more detail about it in a minute. Okay. So for now, byte meaning is 8 bits. Together we call it as a byte. So bit is a single bit, right? Now, what is the meaning of word? Word is basically group of bytes. Okay, group of bytes means what? It's a more than one byte. Okay, byte is 8 bits only. So more than one byte we call it as a word. So this is basically processed as a single unit by the computer processor. Means what? Processor, that CPU, whatever we are using, that CPU works on the words, not on the bit, not on the byte. Means in order to operate, when I say what are the operations the CPU performs, it could be addition operation, it could be subtraction operation, it could be multiplication operation, whatever it is, all the arithmetic operations. Apart from the arithmetic operations, we have logical operations such as AND operation, OR operation, NAND operation, NOT operation. So these all operations are performed by CPU, that is processor, on the word level, not byte level, not bit level. Okay, means what? It is a unit of processor. So it's a fundamental unit of a processor now. Okay, word is. So this word length, basically, when I say group of bytes, this byte means what? More than one bit. More than word means more than one byte. So byte is 8 bit. So this word meaning is, it differs from system architecture to one system architecture to other system architecture. Let us say if it is a 16-bit system, one word is represented as a 2 bytes. When I say 2 bytes, it is 16 bits. Okay, 1 word means what? 1 word equivalent to, in a 16-bit systems, 16-bit operating system, we call it as 16-bit systems, it is 2 bytes. Okay, when I say 2 bytes, it is a 16 bits. Now, if it is a 32-bit system, 1 word equal to 4 bytes. Okay, similarly, if it is a 64 system, 1 word equal to 8 bytes. Now, you understand what is bit, what is byte, what is word. Okay, then let's dive into more detail about it. So we'll see how a binary value can be, how a decimal value can be represented in a binary equivalent values. Okay, let me go through this once. So you can see here, if a decimal value, if you want to represent a 0 in binary, when I say binary, finally all the numbers, all the characters has to be converted into zeros and ones. So before I say about all the character, let us see decimal values. So decimal values, let us say 0, you can say 0 is converted into, let us say 0, 00. This conversion type, one number system to other number system conversion, we have a separate class on that. I'll tell you decimal to binary, binary to decimal, and again decimal, binary to octal, binary to hexadecimal. All these conversions are there in the forthcoming classes, right? Now you understand how 0 is represented here. So 0 is represented 00 in the binary. Binary in the sense it will have only zeros and ones. Apart from it will not have anything. Now 2 zeros. Number, how many bits are there here? Number of bits, 2 bits. Now in a decimal number system, while moving from one number to the other number, only 1 bit change will be there from right hand side. So from right hand side, you have to keep changing only 1 bit. This you remember. So to go, for example, when I say 0, 0 starts with 00. So next number is 1. So 1, if you want to make, keep changing the rightmost bit first and then making the other to the right of it zeros. So let me say that to you again. So let's say 1. Now I am changing the rightmost bit here to 1. So now it becomes 1. So 0, 1 is now 1 equivalent. So similarly, we have, so let us say 2. So as I changed already, next position is what? I have to change to the rightmost position, leftmost position. That means I'm changing here at this position 1. Now 1 0 is 1 0. 1 0 is 2 now here, right? Then what is the next? So I have changed the first position here to here. Okay, first position, and I have changed the second position. Now second position we have to replace with 0 here, right? So now 0. Now what is the value to be changed? It is 3. 3 means what? In the second position, again I am changing here to 1. So left is already 1. It is set. You can't do anything there. But there is an option of again changing the value, as it we have to make it 0. Once we change it, then this 0 becomes 1. Right? Similarly, so now 2 bits positions are filled. 2 are 1s. Now I can't do anything with the 2 bits. So in these 3 cases, I have only number of bits is 2. All these cases, all these 4 cases, 0 can be represented with 2 bits, 1 can be represented with 2 bits, 2 can be represented with 2 bits, and 3 can be represented with 3 bits. Now let us say, if I want to represent 4. So as already 2 are filled in the sense what? 2 are marked as 1, I need to go for the third bit. So this third position I am making it 1, and rest all are I am setting to 0, 3-bit representation now. Now what about next? Now start from the right. So if I want to represent, I have to change this 1 here. So this becomes 5 now here. So it is a 5. So this is done. Now what is the position to be changed next? This. When I change this, mark it to 1 and make this bit to 0. Mark it to 1 and make the right hand side bit to 0. This becomes 6 next. So you can see here. So I marked here to 1 and I made the right hand side bit to 0. Right? And similarly 7. So any of this I have already 1. This I can change here to 0. I mean here this 0 can be changed to 1 here. It is 3 bit. Now again 3 bits are filled here. So now what is the next position? To represent to 8, I need to have increase 1 more bit and make all the right hand side bits to 0. So this is white 8 here, 8 equivalent. Right? Now if I want to represent 9, how can do? So start from the right hand side. So keep changing. 9 means what? 1. Okay. 0. This is the 1 0 0 is 8. 1 0 1 is the 9. Right hand side. Now if I want to make 9, what? This is your 9. And if I want to make 10, what is happening? What I have to do? I have to make the right hand side bit 1 and move the left hand side bit 1 and this right hand to 0. That means what now? 1 0 1 0 is your 10. Similarly, if I want to make 11, you have to always start from the right hand side. So there is a position 0, you can mark it to 1. Now 1 0 1 1, this is your 11, right? Now these two bits are filled, means what? Where I can change here. So you can change, whenever I change the leftmost bit, you have to make the rightmost bits to zeros. Okay, now that means what? So here I am changing 1 1 2 zeros. So this is your 12. Now next, what is there? I have to start from right hand side filling. So 1 1 0 1. Likewise, you can keep on increasing. Now what's the point I am trying to tell you is, so for different, as you increase the decimal value, the number of bits required are increasing. The number of bits are required are increasing. That point you remember. So this decimal equivalently binary, it is being converted like this, and that binary information is stored in the computer. Okay. Now let's see other details. So how about if I want to represent 255? So as I tell, 255 means what? You have to keep on adding or doing all that stuff. It is 8-bit representation, as I said. So I can represent with 255 with 8 bits. Okay. So this is your 255, right? Means what? In a length of 8 bits, I can represent all the values ranging from 0 to 255. Okay, in a length of 8 bits, I can represent all the values from 0 to 255. That you remember. Right. Now, how C converts these numbers into all the characters that are represented in a keyboard to numbers, where it represents always people have to use 48 for 0 and 49 for 1, similarly 57 for 9. So for character 9 on the keyboard, you need to have a separate number decimal value called as 57. For character 0 on the keyboard, these are on the keyboard, there is a corresponding decimal value, that is 48. Similarly, for a capital A, is 65, for a capital Z is 90, for a small a is 97, for 122 is for small z. So for all the characters in the keyboard, there is a corresponding decimal value. And when I have this decimal value, just now I have told you how to represent this decimal in the binary. Okay, this binary decimal, there is equivalent to binary conversion. I'll tell you the methods how to convert to binary to decimal to binary later on. Now you understand. So these characters are mapped to decimal. This decimal have equivalent to binary representation. These binary representations are finally processed on the CPU and also stored in the memory in terms of zeros and ones only. So finally what? All the digital computers works on zeros and ones only. This is the mapping that takes place